Hello dear students, in this video I am going to discuss about electrode potentials and EMF of the cell, electrochemical series and its applications. All these topics are from the chapter Electrochemistry. Students, this is the 10th part of the chapter. Electrode potentials and EMF of the cell, electromotive force of the cell. Students, this topic is common in both the chapters, redox reactions and electrochemistry. This topic is common in both the chapters, that is redox reactions and electrochemistry. First, let us see what is meant by oxidation potential. Oxidation potential. When a metal rod metal is M, rod is immersed in a electrolytic solution containing ions Mn plus, ions of the same metal. Then the potential difference generated between surface of the electrode, students, here electrode means the metal rod, surface of the electrode and electrolytic solution which leads to the oxidation process is known as oxidation potential, Students, for example, we have immersed a metal rod M, metal symbol we are indicating with the M, which is immersed in the solution, the electrolytic solution which containing the ions of the same metal, that is a Mn plus. This is in the aqueous state. So metal M rod is immersed in this solution. Then what happens is there is a potential difference is generated because electrolytic solution will contains the ions of the same metal and the surface of the metal which contains a neutral metal atoms. Then metal has a natural tendency of losing electrons because some potential difference is generated. Metal surface contains neutral metal atoms and the electrolytic solution will contains ions of the same metal. Then metal has a natural tendency of losing electrons. Mn minus gives rise to Mn plus. It has the process, the potential difference which is generated, which will leads to the oxidation process. Loss of electrons, we can call it as oxidation process. That is called as oxidation potential. Standard oxidation potential can be represented as E naught M/Mn plus. M0 elemental state, oxidation state is 0. It is converting into Mn plus. Increase in oxidation state is called as oxidation. Students, here this process will occur to the negligible extent only. If we are removing the electrons continuously from this, then this will move in the forward direction. This has a natural tendency, it will occur, but when we remove the electrons continuously, then the process will go in the forward direction. So students, for example, if it is a zinc, then oxidation potential we can represent it as E naught Zn slash Zn2 plus, which has a value of 0.76 volts, which has a value, oxidation potential value is 0.76 volts. And the standard conditions refers to the standard conditions. Standard conditions are temperature should be 298 Kelvin, 25 degrees Celsius, pressure is 1 bar pressure, and the concentration of the electrolytes, concentrations should be 1 molar. Students, next let us discuss about the reduction potential. Students, next is reduction potential. Reduction potential. When a metal M rod is immersed in a solution, immersed in an electrolytic solution, then potential difference generated, electrolytic solution which contains ions of the same metal, which contains Mn plus ions, then potential difference generated between metal rod and electrolytic solution, which leads to the reduction process, when electrons are provided through external circuit, Students, for example, metal M rod is immersed in a solution of the electrolyte which contains the ions of the same metal. Metal M rod is immersed in a solution which contains the ions of the same metal, Mn plus it is present, and we are providing the electrons through the external circuit. Through a wire, electrons are transferred, we are giving the electrons to the metal. Then it has a natural tendency, when we are providing the electrons, then the potential difference generated between the electrolytic solution and the metal rod, which leads to the reduction process. Mn plus which is present in the solution, it will take the electrons and it will convert into the neutral metal solid. Then it will deposit on the metal rod. Metal will deposit in the form of neutral metal atoms. Whatever the Mn plus ions are there, they will accept the electrons and they will convert into the neutral metal. Here the potential difference generated between the metal rod and the electrolytic solution, that is which leads to the reduction process, we can call it as a reduction potential. Students, for example, if it is a Cu2 plus 2 electrons gives rise to Cu solid. So standard reduction potential E naught can be represented as Cu2 plus slash Cu. higher oxidation number to lower oxidation number. Plus 2 is converting into 0. Reduction potential, which has a value of 0.34 volts. This is a reduction potential value of the copper. So general representation for the given metal, students, E naught m n plus slash m, higher to lower oxidation state, it is converting, it is undergoing reduction, standard reduction potential we can call it as, students. But according to IUPAC convention, according to IUPAC convention, all electrode potentials are represented as reduction potentials only. Reduction potentials only. Students, that means, for example, if we take a zinc oxidation potential, standard oxidation potential of the zinc, Zn E naught Zn slash Zn2 plus value is equal to plus 0.76 volts. Then we need to convert immediately this into the reduction potential. So to convert into reduction potential, E naught Zn plus 2 slash Zn is equal to, the sign will changes, plus will becomes as minus, minus will becomes as plus, minus 0.76 volts is a reduction, standard reduction potential value for the zinc. Students, next let us discuss about how to find the reduction potentials by using the standard hydrogen electrode. Dear students, reduction potential values for a given metal we cannot we cannot measure directly. So some reference is needed. If you want to find the reduction potential value for the zinc, it is to be coupled with the some other electrode, some reference is needed. So reduction potentials of the different metals we can measure by using standard hydrogen electrode. Standard hydrogen electrode, the electrode potential is taken as a 0. It is assumed as a 0. It is not measured value. For reference, we will take the standard reduction potential or the oxidation potential for the hydrogen electrode. We will take it as a 0. If you want to measure the electrode potential of the zinc, then zinc electrode should be coupled with the standard hydrogen electrode. Why? Because neither oxidation nor reduction occurs alone. If there is a oxidation, there is a reduction. If there is a reduction, there is a oxidation. Both are complementary to each other. So to measure the reduction potential values of the given element, it should be coupled with the standard hydrogen electrode. Now let us discuss about the standard hydrogen electrode. Standard hydrogen electrode. Students, in the shortcut it is known as SHE, standard hydrogen electrode. It is also known as normal hydrogen electrode. Standard hydrogen electrode will be like this. Platinum wire is sealed in the glass tube. Platinum wire is sealed in the glass tube which is connected with the platinum plate, PT plate, platinum plate coated with platinum black. Finely divided platinum is called as a platinum black. Platinum wire is sealed in the glass tube which is connected with the PT plate, and this PT plate is coated with the platinum black, and this entire setup is dipped in the solution 1 molar HCl, 1 molar HCl solution. This is 1 molar HCl solution, and into this continuously dry H2 gas is bubbled, blown into this H2 gas at a 1 atmospheric pressure. This is a porous material, because gas should enter into this solution. It is continuously bubbled into this 1 molar HCl solution. Students, this is the construction of the standard hydrogen electrode. So in which platinum wire is sealed in the glass tube, and it is connected with the platinum plate which is coated with the platinum block, and this entire setup is dipped in the 1 molar HCl solution, and into this solution dry H2 gas is blown into this solution at a constant pressure of 1 atmosphere, 1 atm pressure, normal atmospheric pressure. Standard hydrogen electrode in this platinum wire is sealed in glass tube, connected with platinum plate, PT plate, and coated with, that PT plate is coated with platinum block, which is finely divided platinum, and this entire setup is dipped in 1 molar HCl solution, aqueous HCl solution, constantly dry H2 gas at a pressure of 1 atm is blown into the solution. Students, if you want to measure the reduction potential of the zinc, then zinc rod is immersed in the solution which contains the Zn2 plus ions. Zinc rod is immersed in the solution which contains Zn2 plus ions. It is to be coupled with the standard hydrogen electrode now. Standard hydrogen electrode, zinc is coupled with the standard hydrogen electrode. Then zinc is being more reactive than the hydrogen. Zinc electrode will act like a anode. And hydrogen electrode, which is less reactive than the zinc, this will act like a cathode now. This is anode, and hydrogen electrode will act like a cathode. Then students, here salt bridge is needed definitely, otherwise no current will flows. This is a salt bridge which will complete the inner circuit, which will maintain the electron neutrality of the cell. Salt bridge is kept like this. Then when standard hydrogen electrode is coupled with the some electrode which is more reactive than the hydrogen, standard hydrogen electrode will act like a cathode. Then the reaction taking place when SHE acts like cathode, then the cell reaction will be 2H plus 2 electrons gives rise to H2 gas. Gain of electrons is reduction. When SHE acts as anode, students, when standard hydrogen electrode is coupled with the less reactive metal like copper will act like a cathode, then the standard hydrogen electrode will act like a anode. In that case, reverse of this reaction takes place. H2 gas gives rise to 2H plus 2 electrons. Loss of electrons we can call it as a oxidation. So that is the reason why standard hydrogen electrode is called as a reversible electrode. And students, the reduction potential 2H plus E naught 2H plus slash H2 is 0.0 volts. This is not a measured value, this is assumed value. Standard reduction potential of hydrogen electrode is 0. Why? Because this is a assumed value, this is not a measured value. With reference to this only, we will measure the reduction potentials of different metals. Students, next let us discuss about the electrochemical series. Next is electrochemical series. Electrochemical series. Students, different elements are arranged in increasing order of their reduction potentials. Different elements are arranged in decreasing order of their reduction potentials, lower to higher, or you can call it as increasing to decreasing reduction potential values. That is known as electrochemical series. At the top we have lithium E naught Li plus slash Li, which indicates a reduction potential. According to IUPAC convention, all the electrode potentials should be indicated as a reduction potentials only. So Li plus slash Li, it has a value of 3.04 volts. Next, E naught K plus slash K, which has approximately 2.93 volts. E naught Ca2 plus slash Ca, which has 2.87 minus 2.87, and which is followed by sodium Na plus slash Na minus 2.71 volts, and followed by some elements, and then E naught Zn2 plus slash Zn, which has minus 0.76 volts, followed by some elements. Later we have E naught 2H plus slash H2 hydrogen electrode, it is standard hydrogen electrode, E naught value 0 volts. Then after this we have E naught Cu2 plus slash Cu, which is plus 0.34 volts, positive reduction potential, and followed by at the end we have E naught F2 slash 2F minus 0 to minus 1 reduction, which has plus 2.87 volts approximately. Students, so this indicates this is a increasing order of reducing nature, So that means Li is a strong reducing agent, strongest reducing agent. Then this is a increasing order of oxidizing nature. So down this table or the column, the oxidizing nature will increases. So in this, strongest oxidizing agent is fluorine. Students, here the more negative reduction potential indicates it has a less tendency of undergoing reduction. So that means Li, it will not prefer to undergo reduction to form Li minus. Okay, it will not gain the electrons generally. More negative reduction potential value indicates it has low tendency of undergoing reduction, high tendency of undergoing oxidation. So while it is undergoing oxidation, it will act like a reducing agent, strongest reducing agent among all the elements of periodic table is lithium. Lithium will easily convert into Li plus. it won't undergo reduction. Negative reduction potential indicates it has very low tendency of undergoing reduction, high tendency of undergoing oxidation. Lithium is the strongest reducing agent and fluorine is the strongest oxidizing agents. Students, let us discuss about the applications of electrochemical series now. Applications of electrochemical series. Applications of electrochemical series. First application is relative strength of oxidizing and reducing agents. The element with lower reduction potential is strong reducing agent, and high reduction potential RP standard SRP standard reduction potential is strong oxidizing agent. Students, for example, if three elements are given X, Y, Z, they have given standard reduction potentials are provided. If X has minus 0.14 volts strong standard reduction potential, Y has 0.76 volts positive value, Z has 2.17 volts positive value, right? Then the element which has lower reduction potential, this is from the given three elements, stronger reducing agent, strongest from the given provided X, Y, Z, reducing agent is X. So with the more positive value of reduction potential, high positive value, more value of reduction potential, this indicates it is a strong oxidizing agent. Second application is calculation of EMF of the cell at standard conditions. Students, E naught cell is equal to, we can write it as E naught standard reduction potential, reduction occurs at cathode, we can write, plus standard oxidation potential of anode. Students, but generally all the electrode potentials we have to indicate it as a reduction potentials only. So that's why this we can write it as E naught cathode, which is a reduction potential. So to convert this oxidation potential of anode, we should change the sign. So minus E naught anode we can write. Students, for example, if it is cathode is given as a Cu2 plus or copper cathode, E naught Cu2 plus slash Cu is equal to 0.34 volts positive value reduction potential, plus 2 to 0 reduction is occurring, and it is coupled with the zinc electrode. For that oxidation potential is Zn slash Zn2 plus, which is oxidation potential 0 to plus 2 increase in the oxidation potential is given as 0.76 volts. Then to calculate the E naught cell for this, which is constructed by zinc is acting like an anode and copper is acting like a cathode. For that we can write this as E naught cathode minus E naught anode, provided both are reduction potentials. Immediately you can convert this into the reduction potential. E naught Zn slash Zn plus 2 slash Zn is equal to, sign will changes. Oxidation potential is positive. Reduction potential is negative. 0.76 minus 0.76 volts. Let us substitute these values in this expression. 0.34 minus of minus 0.76, which is equal to 1.10 volts. Students, let us see two more applications are present here. Students, third application is feasibility of cell reaction. Feasibility of cell reaction. In the electrochemical cell, the electrode with lower standard reduction potential should act as a anode, and the other electrode should act as cathode. Then only cell reaction is feasible. Students, for example, zinc electrode is coupled with the copper. Zinc electrode is coupled with copper. E naught Zn plus 2 slash Zn is equal to minus 0.76 volts. E naught Cu2 plus slash Cu is equal to plus 0.34 volts. Then when zinc electrode is coupled with the copper, the electrode with the lower reduction potential should act as an anode. It should undergo oxidation. The other one should act as a cathode. Then only cell reaction is feasible, right? And the fourth application is the metals with negative standard reduction potentials can evolve H2 gas from the mineral acids. H2 gas from the mineral acids. So that means with the, for example, a metal which has a more negative reduction potential means that is more reactive than the hydrogen. So then those metals can evolve H2 gas from the mineral acids. So students, these are the important applications of electrochemical series. Thanks for watching.